The brain and its functioning is a very delicate and complex process. It's especially interesting to see what's actually happening in someone's brain when they suffer from a mental illness such as depression. Today, I will explain how a neuron fires and how the gene SLC6A4 affects me and many other people.
This is a neuron. They transfer messages across the brain through something called an action potential. Many cell membranes lie along this neuron's axon, which is the long part. They are responsible for continuing the chain of action potentials along the neuron. First, we will take a look at a cell membrane at rest. On the inside, we have a large chunk of negative proteins, a lot of positive potassium, a little bit of positive sodium, and a dash of negative chlorine. On the outside of the membrane, we've got quite a bit of negative chlorine, a lot of positive sodium, and a touch of positive potassium. But wait, there's more! There's a passive potassium leak gate in which potassium leaks to the outside of the membrane. We also have a sodium leak gate in which sodium passively transports into the cell. It's important to note that 50 times more potassium exits a cell than sodium that enters the cell. And finally, we have an active sodium-potassium pump, which actively transports 2 potassium in and 3 sodium out. Overall, the membrane is shedding positive, so the overall charge of the cell membrane is a negative 70 millivolts. It's negative on the inside and positive on the outside, which means it's polarized. The cell will reach negative 55 millivolts when it receives a message from another neuron. This is because sodium rushes in due to a sodium chemical gate opening. Once it reaches negative 55 millivolts, which is threshold, it will shoot up to positive 30 millivolts due to a sodium voltage gate opening and then plummet back down to negative 80 millivolts due to a potassium voltage gate opening. After this depolarization and hyperpolarization, the cell returns to rest. This action potential triggers the next cell membrane to do the same until it travels down the entire axon. Once it reaches the axon terminal, a neurotransmitter is released to the next neuron. This is where the gene SLC6A4 comes in. Let's say the neurotransmitter being sent is serotonin. A normal synapse, which is where neurotransmitters are sent and received, has many transports for serotonin and can therefore amply produce this neurotransmitter and use it. Serotonin makes you happy. This is why a polymorphism or a variation in the gene can be linked to depression. Those who have a deletion or a short allele, like me, have less serotonin transporters on the presynaptic neuron, resulting in less serotonin transmitting and therefore a decrease in mood. I found this out when I had a genetic test done called GeneSight. Unfortunately, this also means I am genetically predisposed to depression and may have to continually take medicine to ensure my serotonin levels are where they should be. Although it's hard to study the brain and mental illness, there's a lot we already know and much, much more to learn. It's only human to keep exploring until we know all that we want to know, and I'm excited to see what we discover next. Thank you.